Hi, my name is Nate Lau. This is a demonstration of my CUDA fluid simulator. This was implemented using my machine. It's a Debian Linux server with an RTX 3060. To start off, let's run through the source code. So this is my main point of entry. On the top, I define my dimensions and other constants that's used in the calculations. The critical point right here is the CUDA grid and block definition. The dimensions of the blocks have to be 32 as per CUDA 2.x, and the grid dimensions are based off the resolution that you desire, and resolution is actually defined in the dimensions. Uh, this section right here allocates the device and host buffers for both the scalar and vector fields. The only vector field that is used is the velocity vector. It's used in two dimensions, so every vector has two components to it, and the two scalar fields are the pressure and divergence fields. The last buffers that I use are the BGR fields, which are unsigned 32-bit integers, and these get converted later. At the control loop, we basically go through the calculations of advection, divergence, pressure, and boundaries, and this all gets set in the appropriate fields. Tracing back, after calculating a frame, we copy that to the host, and that's for use for debugging information. The host fields are not really used for doing any mathematics. It's just so that the CPU can see it so we can print it out. Um, and then we convert it to the BGR pixel field. And all of this else right here is just debugging information for FPS and rendering to video. Alright, let's go ahead and demonstrate this. Let's pull this away and let's compile this over. I'm SSH, by the way, into my server, so this should just take a couple seconds. Cool. And to run the binary, it's in the bin folder and it's just only the main. Let me pull the windows over real quick. I've added debugging information in the terminal so we can see a live view of our FPS, our velocity, and divergence and pressure. Wherever my mouse is on the velocity window will reflect the values here. For some reason it's kind of slow, so it doesn't really match the FPS, but it could be because of the carriage return or something weird. But on the other hand, rendering this is actually pretty fast. So if you click onto the velocity window, you can add an impulse. Note this is calculated in real time. There was a small bug about leakage on the corners, but that was just because of a boundary condition and some technicalities. But you can actually see the waves interact with each other as you impulse the fields. As you increase the dimensions and resolutions, the performance will take a hit. My recommendation for that is to not render the divergence or pressure fields and just render the velocity. I consider this more of a hello world example. I did not have time to render ink interaction, so the velocity field is just the velocity. You can imagine that if you impulse, you're adding ink to the system, and then you can actually follow it, and it will diffuse over time. You can kind of see the interactions with waveforms occurring. If you look real closely, you can actually see some artifacts from the CUDA kernels. If you see straight lines that happen, I believe that's because the grids are not being processed at the same exact time, so there's kind of tearing on the render, or it could be an artifact of OpenCV. Overall, I found this project pretty fun. I really just consider it as a hello world. I'm not that sure of my mathematics. I'm not that sure if I'm calculating correctly. I think someone with a physics degree needs to look into my software, but so far it's acting like a fluid. But I encourage people to give this a shot, try to do it on real hardware. I'm not sure if X forwarding is fast enough because this kind of dies with Wi-Fi, but overall this is a pretty fun project to do. You can see the divergence fields kind of indicating points within the waves, and pressure is a derivative of that. Alright, thank you.